So today for us on the keyboard is Provod of Jetlag, and he will try to entertain us with some shader coding. Let's see what we will come up with. All right, good opening, removing some of the stuff that's there by default.
Okay, I'm done.
All right, perfect.
Huh? I think. Huh? No, we need to restart the thing for font to be bigger. Like there's a. Okay, let's.
Alright, so for your viewing pleasure, we will increase the font size, or attempt to do so anyways. Yes, already live coding / configuring.
Is it better?
Yes.
Alrighty, so now we can all read.
I can make it a little bit more bigger if you want, but... I can type.
Alright, so what we can see here is a bunch of built-in variables that sort of give us something like screen resolution, screen size, and so on and so forth. Let's not worry about that too much, and let's maybe enjoy it for a minute or two, and see where he's going with whatever he's writing. So far we're setting up a bunch of values, and yeah, that's what we're seeing so far.
I'm just writing down the basic Ray-Marching boilerplate.
Alrighty. So there's two strategies that people are doing. Some people are compiling very often so that they see changes all of the time. Other people tend to write lots and lots of code and then compile. So I think both of them are good for the audience, because if you see the compiling very often, it's you see what's going on, and if you see the compiling not very often, you get surprised and there's tension building up. So you get the best always. Alright, we have a sphere. Can we get a tiny applause for our first sphere? Yay, we're seeing something good. By the way, I would never do this, like live coding. It's like, for me, it's, you know, when you're in a test and the teacher is standing behind you and looking at what you're writing, I couldn't do this. Too much pressure. So I have the highest respect for our contestant.
So you like spheres, right?
Yes. Oh, now we have 4 of them, I guess. Oh, that's a bit more than 4 spheres. So what we see here is the modulo repeat trick, which is basically domain repetition. These are very fancy math words that I'm using, I know. Alright, now we have colorful spheres. Basically what we see now is the color of the direction of the normal vector. That's the vector that's perpendicular to the surface of the spheres. And we see the x, y, and z coordinates represented as color. And correct me if I'm saying something wrong, right? Oh no, I'm not breaking his concentration again. I learned that now. Good, good. Wii movement.
So these were some super basic ray marching things that not really interesting, but now I will do stuff that seldom done in ray marching.
Okay, for the academics between you, in these circles of SIGGRAPH and so on, the favorable term that's to be used is sphere tracing. But we like to call it ray marching. Ray marching is fine. Everybody knows what you're talking about when you say ray marching.
Why not? If you could see it, if you have it in front of you, if you can see it, then why not?
There's a lot of boilerplate code to write. Let's write some noise.
I think you're also allowed to use text noise if you want to.
I don't like it.
Okay, good. Good decision. We want high quality noise. For you, the best audience, we have only the best noise functions. With the most random values.
These are random characters, like, yeah, whatever.
Yes, that's why it's called noise. Ah, it's getting a bit noisier. Okay, so we just saw the one-dimensional noise, which was represented by the dark and light, not so dark lines from left to right. And now let's see what our candidate is going to do next with this random noise. Probably, I have a guess here, he's gonna apply it in more than one dimension. That's usually the trick for 3D graphics, use more than one dimension. So I've been wondering what programming languages would look like in the future, and the only thing I can come up with is more character support for emojis. So who of you would like to see a programming language where you can type emojis in your programming code? No one? Okay. Good. Oh, it's only me.
I think you can type emojis in C++ at least. Like they are supported as a. Like,
okay, shall we find out? No, let's not. This is all bad ideas for your entertainment. Okay. I am going to venture a guess that somebody's trying to implement a depth of field effect.
yes.
Ha! I am so good at what I do.
But I'm not.
No, you're getting there. It's good. Just keep doing what you're doing. So yes, this is what live coding is all about. You fudge with the numbers until it looks good. Or you do what he's doing.
Okay, this is what I don't like about live coding. So if something doesn't work like from start, like you have no idea how to fix it because like it's super stressful.
Yes, that's usually when we move on to something else and pretend that we intended to do that in the first place.
Okay, I will do something else.
Okay, can we guess what this something else is? Anyone? Audience? No, me neither. Good audience. I'm so paying attention. Whee! Isn't that fun? In not so many lines of code to have this much of a, well, let's call it detail. All those planets are belong to you. Yeah, maybe some spaghetti with the meatballs? Yes, some spaghetti with the meatballs? No? No spaghetti? Okay. Okay, now I am even confused why the normal vectors don't look like normal vectors anymore.
Normal vectors are fine.
Okay, apparently we moved on to Star Wars, the early years. So for reference, we do these things at demo parties usually as a competition where two people shader against each other, so to speak. And in that format we use maybe 20 to 25 minutes, which would put us for this shader around about at halftime. So if this was a competition, now you would sort of start to get an inkling who's in front, who's behind, and who does the crowd like more for. We do crowd voting by applause, mostly, so. And I think this one would be an applause, I think, yeah, definitely. Don't applaud, not yet. I think my worst fears of doing this would be that there's somebody who's talking shit all the time and throwing me off my game and making me not concentrate, yeah. Okay, one of the things that sort of makes it a bit harder for the commentator is, obviously, since we are pressed for time, nobody of the contestants of any shader contest ever takes the time to use proper names for their things. So it's all like A, B, C, F, Y, ham. But that makes it so much more fun to figure out what is actually going on. I have no idea what's going on. I wonder, is there like an ASMR for like keyboard? Is that a thing? No? Okay. So this shader turned communism for a tiny bit, but now it's back. It's good. Oh, no, it's partially communist. So at this point, I am so out of ideas that I'm going to explain data types. So vec3 is obviously a vector in 3 dimensions with 3 components, either x, y, z or RGB. I think that's all the data types we're using, so that was not really a good idea. I haven't thought this through at all. Yeah, we can see the max function, which is obviously the maximum. We can see the dot product, which is the cosine of the angle of 2 vectors. Whew, all the things that I don't know that are also on this page. Lots of them. I think I finally know what he's making. Cookies. No cookies? No, I get it now. No cookies. I'm sorry.
Just for the record, I have no idea what I'm doing.
Oh, that explains it. Ooh, I think we're coming into reflective territory. Obligatory joke for Google employees, Chrome cookies. Okay, now it looks like there are tiny spheres inside of a bigger sphere, so it's a kind of sphereception, I guess. Oh, and the music's back! So my worst fear for doing the commentary was that I was afraid I was going to run out of good one-liners halfway through the thing, so... We're at half now, so yeah. That's where we are. So I'm gonna venture a guess what we're seeing here is a gradient calculation?
Yes. No.
Yes, no, maybe? I'm wrong? Good.
It's a trilinear interpolation, something like this.
Yeah, that's... I'm gonna call it gradient, it's fine. Right. I think this is a tiny applause. Come on, guys. Ah, the miracle of life. I hope nobody of you has a photosensitive epilepsy. Otherwise, I would be legally inclined to tell you to not look. Good, so far nobody. Good. We're all good. Good. Okay, I'm feeling a bit like a microscope inside of a cell. I don't know about you guys. Alright, that's good. Sorry, I just had an outburst, but this looks really, really good. This is it has like a depth of field effect, so you see like a camera focal plane, and there's all these paprika or whatever they are, and now it's going really, really slow. No, we're back again. And there's peanuts or whatever. So yeah. Oh, I see, we have a guest. Hello. We have like, I don't know, about 20 minutes left. Do you want to do something?
I always wanted to do it.
Okay. We could create your own like hot dog.
Yeah, I can draw some like umbrellas and stuff. I think that'd be like 20 minutes.
Okay. Good luck, you're getting the job. Whoa. Alright, who thinks this is trippy? I think this is getting like really, really trippy. So, by the way, timing, we have about 15 minutes left, so okay, now let's think. What can we do in the 15 minutes that are left? Maybe some different colors? Maybe a flashy glare? I am not even sure. This thing can do post-production effects like render to texture, right?
What?
It can do render to texture, and you can do like a full screen effect on these things.
No, this is Bonzomatic. It can do post processing.
Yeah,
So
on
it's
this.
a-
Yeah, greetings to Guy who wrote this piece of code, which apparently can't do post effects. Good, good. Nice going, Guy. Okay, we have about 10 minutes left, so let's give a tiny applause and cheer our candidate. Come on! You can make this shader so much better. We believe in you. Now we have a question from the audience. Please repeat the question. Yes. So we're seeing the code is overlapped to the shader that's running sort of in the background. But we can sort of also go into the full screen mode. And now we only see the meatballs. Well, I think for the no, I think it's like one OpenGL context where those two things are overlaid, and I think there's like no real projection going on for the text layer. It's just GL coordinates. Yes. Cheers. And we have about 8 minutes left. 8 minutes. Alrighty, so we're approaching the final 5 minutes. Final 5 minutes. Ooh, is somebody using text noise? The unwanted text noise. I think we should be more fair to certain textures. They all belong with us. Textures are good. We like textures. All of them. No texture is illegal. Doesn't matter what the driver says, but I say that. There will always be something in memory that we can read, so therefore no texture is illegal. Yeah. You can quote me on that. Okay, final 3 minutes. Now in a competition, this would be the moment where you could decide as a programmer, am I going to risk to do a large change and maybe break the thing and make it not compile, or am I content with what I have and just like tweak the colors a bit? Since this is not a competition, I think neither applies, but I was sure to mention it anyway. Also, I still want cookies now. Is anybody has the same feeling about like cookies? Alright, 2 minutes. Usually we have a rule in the demo scene, which is never make brown bump mapping. Oh, 2 people got the joke. Good, good. But since this is not really bump mapping, I think we can let it slide. And we're in the final minute. Final minute. Okay, 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, and done. Dunsies. How do I turn this on? All right, put the pencils down. Hey, do you want to say something, or show us a part in the shader where you say, oh, I am really proud of this part, or this part I didn't do well in?
So what I've tried to do is kind of a soup of cells or something like this, and I
so like a protozoa?
Yeah, something
Okay.
like this. So and I kind of failed, right?
Well, I mean, if it's on a cookie planet, then you succeeded.
Yeah. So from design standpoint, like it's really I couldn't do the actual colors, but the idea there, like there's a depth of field which is like really strong, so it kind of tries to simulate the this microscope-ish camera.
Yeah, very good, very good.
And there are refractions, so if I just do so you can see that actually when ray hits the cell boundary, it like refracts around it, through it, and but yeah, it's kind of hard.
Yes, so I think that's pretty nice. So let's give him a hand, our candidate, once more again. I think he did great, much better than I would have done. And I don't know, where's Joe? So what's up next? Does anyone have a timetable?